Hi, my name is Jacqueline Theis, and I am a practicing optometrist in Richmond, Virginia. I practice in a private practice called Virginia Neurooptometry, where I see patients with brain injury and visual disorders from neurologic dysfunction. The other hats that I wear multiple hats, but one of them is I also work on the AOA's evidence-based optometry group. And so we write the clinical practice guidelines, which was a really wonderful opportunity for me to recognize just how much of a need there is in optometry to get people to really understand the foundational basis of the importance of evidence-guided practice. And I say that because one of the things, so in this myth-busting lecture that I did with Dr. Morgenstern, what we really looked at was understanding that there's a hierarchy for the importance of reliability of different types of trials. We know that a case series might be clinically important, but the statistical methodology of that is going to have a lot of issues because it's a small sample size. You're going to have selection bias and recall bias. And so we know that the RCTs, right at the top of that pyramid for what's the best evidence, a randomized control trial is going to be wonderful. But oftentimes they narrow down their patient population so much to be able to show the statistical difference with their treatment that it might not be clinically relevant. And so we really spent a good time talking about how to read a study, how to assess whether, is it statistically significant? What does a p-value mean? What is a confidence interval? Why is a confidence interval more important to be able to understand how that might apply to your own patient base? And then how to tease out sometimes, the title of the lecture is that sometimes researchers lie. And I really want to hit home with, it's more of an adage that sometimes you can manipulate the statistics to be able to look like something was really efficacious when it wasn't. And being able to tease that out as a clinician or to recognize, hey, this was a really efficacious treatment in this clinical population. But it wasn't in mine because my clinical population, especially in my clinic, is everyone that's in the exclusion criteria. And so we don't know what that treatment will look like or work on for my patient base because of that. The first thing I always do when I open up a study is get rid of the title and the abstract, and I'm going straight to the methods section. So the methods section, you need to know what type of study was it? How did they do enrollment? I'm always, the second I start reading, I'm looking for different types of bias. Just because there's a financial bias or a selection bias doesn't mean it's a bad study, but I need to keep those in mind when I'm interpreting the data so that I always have a critical eye to make sure that what they're saying in the paper is actually true. And we all know that, I also look at what type of journal is it. Is this journal a peer-reviewed journal? Do we have people that are looking to make sure that the study was sound? Or is this just a pay-to-publish kind of journal? And so kind of recognizing that to be able to really make sure that the evidence I'm going to use to guide my practice is sound evidence. So some of the tips when you're reading through the study is looking at the inclusion criteria and the exclusion criteria. If the inclusion criteria is a group that isn't your patient base, you have to keep in mind that that might not work in your group. If the study is based off of, 8 to 10-year-old children, and I only see people over the age of 95, that's going to be an issue and a disconnect with your clinical efficacy versus the research effectiveness of their trial. The other thing that I'm going to look at when I'm reading through is how many people did they have? What type of statistic model did they use? Because there are certain statistical models that you should use depending on the type of study, whether it's a cross-sectional study or a cohort study. And then some of the other things that I look for is just, does it make clinical sense? Someone can have, so a p-value is just telling me that there's a higher than likely chance that this effect was not due to probability, right? But then the confidence interval lets me know, how widespread is that data set as far as its effectiveness? And one of the big things I always like to notice is because sometimes I'll see people's data and they can manipulate it and say, we saw a 35% increase in XYZ. And then when I ask them, well, how, let's pretend it's a optic nerve study and, well, how big is that increase? It's 2 microns. Well, 2 microns is within the error range of an OCT, in which case that's not clinically relevant to me to get someone, 2 microns, even though statistically it might be significant, and even though it might look like a very large percentage change. So that's why for me, keeping on that clinical hat when you're reading research is really important, because just because it's statistically significant doesn't mean it's clinically significant. So one of the things that we went over in our lecture was understanding the different phases of the FDA clinical trials, so phase 1 through phase 4, and where that plays in the regulatory piece. But the other thing that we talked about, which I think is really important for clinicians to know, is what does it mean to be FDA registered, right? My company just registered with the FDA, but no one ever actually fact checked or looked at my data or looked at my device to see if it does what I say it does. versus FDA cleared. When you're FDA cleared, that means that you went through a regulatory process, usually to show the FDA, hey, I have something that's very similar to a predicate device that was already FDA approved. So they've looked through the data, they make sure that your device is reliable and valid and repeatable. And then that's what FDA cleared means, or 510K cleared, things like that. And then approved is usually for a de novo device, meaning no one does what we do. So we have to prove that we do what we do. Or if there's, a pretty high safety issue, that has to be FDA approved. And so the beautiful thing about the FDA is that they do a really great rigorous process to be able to make sure that what you're using on your patients is safe, efficacious, and also valid. I was walking around in our exhibit hall, and it was just a little aggravating to me when you would go up to a booth and they'd be like, yeah, we're FDA approved. And I always say, for what? Because the way that they sometimes have their marking makes it look like they're FDA approved for one thing, but they're actually FDA approved for another thing. But all they're saying is, yeah, we're FDA approved. And so it's important to ask whether it's pharma or whether it's a diagnostic device, what is your FDA clearance? And recognizing that if they just say, oh, we're registered with the FDA, that means that no one has validated their data. It does that what they say they measure, no one has validated that. And then FDA cleared and FDA approved gives you a little bit more safety, but you need to know, what are you FDA cleared for? What are you FDA approved for? Because otherwise you're oftentimes going to be using that off label. You're allowed to use things off label, but the big thing is you have to take on that ownership of it might not work. It might do different things. If it's a different population than what they were approved for, you might have different safety things to consider. So it's just something to keep in mind and to have kind of a critical thinking hat when you're walking through the exhibit hall. I really hope that optometrists start getting more involved, not only in research, but just making sure that they're reading the research, that they're getting involved. And also, if you haven't already looked, the AOA has wonderful clinical-based practice guidelines. They're right on the website. You can find them by typing it into Google. And we're always coming out with some new papers. So keep in mind that we're doing a really good job on the EBO to look through the evidence and really help guide clinical practice.